Let's see what else is on our program. Where did I put it on the word? All right, we now at SRF noise level. I'm going to do a quick introductory presentation on that, and I need to find it. I spoke to Leon, the other Leon, about the problem, and it looks like the incompatibility between the laptop and the projector actually has to do with the frequency setting. And unfortunately, it's a software change that needs to be made, and it won't happen in like a very short period of time. So, Anton's going to present shortly from this laptop, but when he does the practical one, unfortunately we'll have to use the other laptop again. But let's just look at RF noise floor measurement. The International Amateur Radio Union Region 1 President, Don Beatty, he said that if you live in a metropolitan in the city area, HF almost becomes an impossibility because of the amount of noise that's being generated on the RF bands. And actually it's so bad in some places, and here is referring back here to London, that most signals are swamped in the noise. Now if you think that we in South Africa are far away, we're not actually that far from that starting to happening with us. If you live in the city, it really becomes very noticeable. If you live in a country area, it's a lot better. But there's an interesting way of looking at it on how over all those years this has happened. Because if you look at the first signal between South Africa and the US on 36 meters at the time, so that's pretty close to 7 megahertz. It's, what's it, 6 something, 6.8 sort of megahertz in that area. If you look at that signal there, they were using, the guy was using about 30 watts maximum. All antennas they had was a dipole. And they could have communication with the United States at a very, very good signal. Now you try and do that today. You can do it if you're on the right frequency with the right amount of solar flux and the right amount of sunspots available and propagation through the ionosphere. But they must have been using the ionosphere. There's no way that 36 meters would have gone over the ground. And they had very solid signals with that simple structure. And if you think about it, their receivers were very basic. I mean, it was still a couple of triodes, and they didn't really have anything very fancy. And I think they weren't superheads in those days. I think it was probably tuned radio frequency or something like that. I'm not even sure what he used. But those signals were great. Now, if you try to do that today, and if you look at the sun or the ionospheric cycle, or the sunspot cycle, when he did that in 1925, and if you compare that to the sun cycle today, we're more or less on a par. That the sunspot cycle, or the cycle, solar cycle, was about the same then as what more or less what we're experiencing now. And if you compare those two, you find that it's really a concern. Now another publication called Radio World reported similar problems facing AM broadcasting in the United States. You know, we're not using that much AM, although those of you that are old enough to remember LM radio is back on AM in Gauteng, actually quite good signals. And yeah, it's on 702. It's a bit of a like kind of contradiction, you know. You listen to LM radio on 702, it confuses quite a few people. But that's we're not as bad as in that situation. But you think that in a lot of areas, when in the time of AM, They used actually quite low power transmitters because you had all these local stations, and particularly you find that still in the US where you have that. And I think in South Africa we're going to see this happening because the FM bands are full. DAB or what do you call it, the other one, DRM, they haven't decided. We still can't get past the digital migration, so before we do that, we first have to do that before we go to the other forms of radio transmissions. But I think we're going to see a lot of AM stations, small AM local stations with community radio appearing because there's no more space on the FM band. So to them, a noise level is also going to be a problem. Now the SEC, that's the Federal Communications Committee, that's the equivalent of ICASA in South Africa, and the International Telecommunication Union agree that from DC to 60 gigahertz wide spectrum, background noise floor is increasing more and more, mainly due to unregulated electronic devices, and are used by more consumers in more ways every day. Now, on the 15th of June 2016, the Federal Communications Commission's Office of Engineering and Technology, their advisory council, opened a noise floor inquiry, and they issued a docket to seek answers to some of the following basic questions. Is there a noise problem? I think most people that just listen to 702 or 5FM or whatever on FM wouldn't really say to you, no, there is no. But eventually they will also experience problems if we don't check it out. Where does the problem exist? Is it spectrally? Is it spatially? Is it temporally? Now, a lot of these interference signals, or the increase in the HF noise level, is temporary because it happens when somebody switches on. And some of the work that Anton has done is quite interesting. When you look at the graphs, then you can see that there is the sporadic sort of increases in the general RF noise level on a band, and you find some during part of the day it will reduce and then it picks up again. And that could be because of people switching their computers on and off in the neighborhood. There could be 1,000 reasons which we don't know. Right? Then, is there quantitative evidence of the overall increase of the total integrated noise floor across various segments of the radio frequency spectrum? And the answer is no. There definitely is no work done on this. And the question then comes and says, how should we do a noise study? How should we perform a noise study? Now, unfortunately, all these people that said, yes, it's necessary to do that, and they are the FCC, and that's ICASA, and that's the SABS, and that's all the other organizations around the world, unfortunately, they all say yes, but they don't actually have quantitative data to say the reasons why it should be done and whether it is really a problem or not. This is because the responders do not have instrumentation, they don't have the financial resources, they never budgeted for a thing like that, and in most of these organizations it's very low on their priority, and that's always the problem now with our world. I mean, we wouldn't have all this climate drama if we'd known about climate change and did something about it 20 years or 30 or 40 years ago. And the same thing is going to be with the RF spectrum. If we don't do something about it, in 20 years from now, we most probably find that the spectrum is almost unusable. So, despite the scarcity of quantitative data, one clear outcome of the Technical Committee inquiry was an unmistakably a noise floor study not only needs to be done, but it's long overdue. Now, it's very easy to say that for a government department, but you know, if they start budgeting, doing things like it, it's going to take a long time before it will happen. Now, the SABS TC73, that's Technical Committee 73, deals with EMC, electromagnetic compatibility, and RF noise floor studies falls in their ambit, and they have identified, SDR pointed out to them, that this noise floor increases in the RF noise, so particularly in HF, is a major problem, but it will actually spread to VHF and UHF and other areas. And we're now in the world of IoT, everything has to be connected, has to work, but they're all very low signals, but nobody's really considered that if you don't do something to stop noise generated by all these dongles and all these kind of things that we have in our pockets and that we have at home and the baby alarm and you name it, even the fridges. If we don't do something about that noise level, we find that those units, those sensors will not be able to actually communicate. So they will then have to start increasing the power level of those very low power sensors, and what will happen to that? You generate more noise, and so it becomes a vicious circle. So working group 3, which is chaired by ICASA, and the person from ICASA that is chairing that apologized, he's at a funeral today. He was at our previous meeting, but he couldn't be here today. He is then tasked to consider the SRR proposal and make recommendations to TC73. Now, how the SABS is structured, the Technical Committee 73 is the overall committee. Then they've got working groups under that need to like do all the investigations. So while we have sort of step one that they've recognized there's an issue, we haven't got any further than that until the subcommittee meets, and I'm pressurizing them for the subcommittee to meet so they can investigate it and then make a recommendation to TC73 when it meets at the end of November. They only meet twice a year, and that process will take a long time. So it will be a very long process. So therefore the SRR was considering to use the power of amateur radio to study the situation on the amateur bands, because we have we're in a unique world, because there are a lot of us, and all we need is a handful in some area, in several areas, to participate in this project, and then what will happen is we'll be able to do quantitative studies. But yeah, it's easy said than done, and I'm not going to say too much about the graph, but Anton's going to talk about that, but he actually did that graph, and that graph is over a period of a couple of weeks. And as you can see, that there are definite variations. But if you see when he started doing that in the first week 25, 27, then all of a sudden it started increasing, and that increase in noise level actually was maintained over week 32 and week 33. And I think the one in the middle is most probably when he was sitting at the beach somewhere in the south of France or something like that. But that's maybe the reason. But it shows a clear kind of like, now we don't know why that is. That could be temporary, because now if you continue that monitoring and that what was the frequency then?
1 day.
Was it on 1 day? So if you continue doing it, over a period of time, maybe next week or next month or the month after, it could change again, because somebody in the neighborhood that's caused all that noise where he lives may have moved out. So therefore you need to do it over a long period of time with as many people as possible. Now, in this workshop today, we're going to talk about the SDR as the instrument for this, because it can be done manually, of course, but an automated setup would be far better. Maybe we'd need a server somewhere where we can, where all this information that you collect at your station can be uploaded so it can be analyzed. So where do we start? Well, we need to set up a steering committee. We need to set up 3 or 4 guys that actually work on the project and put it finally together. We definitely need to create more awareness. And that's the same problem with our propagation study on 5 megahertz. A lot of people come in and they become very enthusiastic and they switch on their system that they've created on Whisper. But what they do is they switch it on when they're there, and when they want to talk on the air, they use their rig, so they switch it off. They switch